Hi, today I'm going to show you one optimization that I found or that I actually accidentally came across, and maybe will make your understanding of the semantics of host object and native state a little bit more complete. So the question is, can we make host objects as fast as native state objects? If you don't know what host objects are, I made another video about the topic. You can go watch that first. But they're basically a way to expose native C++ objects into the JavaScript context for React Native. Now, the question is, how does a JavaScript object work? So let's say I create my object, right? Like, what's the backend implementation, the native implementation of this object? And there are two ways that a JavaScript object can be implemented. If the shape does not change, then the just-in-time compiler can optimize it, right? It might use a hidden class, it might use stack allocation, CPU registers, etc. It depends on which JavaScript engine you're using. But if the shape is constant, it doesn't change, it can be really optimized and it can really give you like a fast access pattern um, to the properties of your object. But what if it does change, right? Like what if you delete a property, if you use a dynamic key, if you insert the keys out of the specified order, then you have to fall back to a more uh, dynamic implementation, let's say, where you can easily change stuff. And then the backend implementation reverts to a hash map like, it depends again on which JavaScript engine structure. So what's the problem with hash maps? Hash maps do not have constant access. So let's say this is a naive implementation of a hash map. I want to set the property cat and a value of 10. So then what I would do is I would take the hash out of my key and that will give me a bucket index. Now on that bucket, I will append the key and the value that I want to insert. Now let's do the same with another one, right? Let's say with a dog. And for this example, the hash that dog produces is also the same. It also produces the index 3. So then we will append. So how will the hash map look in memory, right? Like how does a hash map is actually implemented is that it will have buckets where the data will be inserted, right? It's not that every single key that you insert into the hash map has its own memory space. So then both of these values end up in the same bucket. So now let's say I want to retrieve my dog key. I will do the same process. I will get the hash, I will get the index, but once I have the bucket, I will have to crawl through the entire bucket to get the value that I want, right? So then you can see the access is not direct. Like I still have to go through a certain amount of values to find my key. So now let's go back into host objects. Host objects are an interface. It's a contract that dictates the access pattern, right? So we have some properties that we need to fulfill in order for the JavaScript engine to interact with our native class, in this case, my host object. But what's important to note here is it is just an interface. Now, where does the slowness come from? It's this linear access, right? We only get this interface, which is the get function, and internally we have to implement it in a way that we declare which properties does the object actually has and return the values. This is not inlineable, it's not cacheable, and it's actually slower than a hash map implementation, especially if you have a lot of values, right? Because you will iterate through every single known property of your object. Now let's talk about native state. Native state is a different interface that allows you to attach a native C++ class to instances of a plain JS object. So I declare my C++ class, its properties, and I just extend the native state interface. Now, how does this work? This works by when I create a new JavaScript object, I can just attach an instance of that class into the JavaScript object. Now, where does the speed come from here? It is actually because it is a plain JavaScript object, even though I'm interacting with it from the JSI side, I can just declare properties on it, right? And I can, for example, in this function, I create an increment and I just, inside of that JSI host function, I retrieve the instance of the native class that I have attached to it. And then I have access to all of the properties and functions of that native class. And again, this behaves like a normal JS object. It makes the access faster, but it's not necessarily direct access. But one important thing to take into account is that host objects and native states are just interfaces, right? They're just the contract for the JS engine to interact with your object. Can we make a host object just as fast as a native state object? Well, if normal JS objects are backed by internally by a hash map, what if we give our host object a hash map, right? So in this case, I'm going to create what I call a function map. And then when I initialize the object, I am not going to put every single prop name into the get function, but I'm actually going to create the functions at once and then insert them into my function map. So in this case, you can see in the constructor on the function map, I'm putting answer method, and then that returns a value. So then later, when I'm implementing my get accessor, I'm just going to go through my hash map, or let's say I'm going to first check that my hash map contains the key that I'm trying to access, and if it does, I'm just going to return that function to be called. Now, this, of course, still gives us a little bit of runtime cost because the interface is still the same. Everything is still going through that get function. But if you think about it, we have now implemented the naive version of a normal JS object. This gives us the same performance, at least until some just-in-time magic kicks in. And here's important to remember. Interface just declare the contract. The implementation is up to you, right? Why would you want to do this? Because at least in my opinion, host objects have better semantics. When you're writing a lot of C++ code, it's easier to write everything without this magic jumping between the JSI world and the native world. You already might have like an existing library that you already written in host objects. So if you want to optimize that access pattern, you can do that. It's just one more tool in the optimization arsenal. And if you really understand how the JS engine works, how JSI works, what are the interfaces, what they behave like, it just allows you to write better code, right? It allows you to do a little bit more magic in everything. So that's it, guys. I just wanted to explain this little bit of magic.